Hello everyone, this is Don with the Physics Instructional Resource Team, and I'm going to talk to you today about one-dimensional motion. So you might have already been learning that some object can have a position in space, and as that changes over time, it has an associated speed. The change in position over time is speed. Or if you're talking about displacement, which is specific points, we call the change in displacement over time velocity. And similarly, the change in velocity over time is called acceleration. And you're able to get the velocity and acceleration if you're only given the position data. And so what I have here is a cart that can move freely on this low friction track from left to right, so one dimension. It's got this motion sensor which will feed data into the computer, and this computer can computationally find, based on just the position data, what the velocity and what the acceleration of the cart are. So when I click collect here, I'm going to give this thing a good push, and we should see a nice straight line. So you can see that it is pretty linear. Again, there's no way to completely eliminate friction, so there is a slight, very small force acting against it. And you can see that based on this position data, this software can give us the velocity data. And you can see it is almost constant, just a little bit of loss due to friction, but it does show us it was moving at about 1 meter per second. And you can take the slope of the position data, which is like taking the derivative, and you can find, okay, it was 0.9. It was almost 1 meter per second that it was moving at. Now, what about the change in velocity? Well, it can also do that as well in the same exact way. I move this velocity data up. You can see at the beginning and at the end of the velocity, there's a spike in acceleration in the positive direction because it's moving positively. And then when it hits the end, it breaks really suddenly. We see that as a negative bump in acceleration.